In section 3.2, we're going to be solving linear systems algebraically. The two methods that we're going to do this are substitution and elimination. The first method that we're going to go over is substitution. Now, this method is a little bit lengthier, but we can break it down into 3 steps and how you would solve anything using substitution. So, in this system of equations, if I wanted to solve, it would be difficult to take either one of these right now because they both have 2 unknowns or 2 variables. Unless I could get this down to a 1-variable equation, I don't necessarily have enough information to be able to solve it. So, how I'm going to do this is I'm going to isolate one of the variables. Once I get a variable by itself, I can plug it into the original and go from there. So now I'm going to look at my equations and I'm going to see that this y in the second equation can be taken by itself in one step. So this is the variable that I'm going to isolate. If I subtract the 2x on both sides, I'll be left with y equals 10 minus 2x, and now I'm good to go. So in the second equation, wherever I see a y, I'm going to replace it with a 10 minus 2x and go from there. So this next step is going to be to plug in and solve. So I still have y equals 10 minus 2x. So we're in this first equation, wherever I see a y, I'm going to replace it with this value here. 3x plus 4, instead of y, I'm going to do 10 minus 2x equals 12. So while this equation looks kind of ugly, what's important to notice is that there's only one variable. So even though this looks kind of long, we have enough to be able to solve it. We just have to combine like terms and get x by itself. So from here, I'm going to distribute on both sides. The 3x and 8x are on the same side, so I'm going to combine that to be negative 5x. Subtract the 40. Divide both sides by negative 5. Now a negative over a negative is going to turn positive. You're going to be left with x equals 28 over 5, or 5.6. So now, after we do step 2, what I'm going to do in this last step is wherever I see an x, I can do it in either equation. I'm going to plug in a 5.6, and then I'll get y by itself. So x equals 5.6. I'll do it in the first equation. I get 11.2. I'm going to subtract both sides by 11.2. And I'll have this. So if I were to graph both of these lines, they would intersect at the coordinate 5.6, negative 1.2. The next trick that we're going to learn is solving by elimination. What you're going to find here is that elimination is a much quicker method than substitution. So if you find an equation, which we're about to see, where elimination would kind of like match up, or you have 2 terms that would match up, definitely go for the elimination method. So whenever I see a situation like this, here I have a 4x and I also have another 4x, or in other words, I have 2 terms, the same variable and the same value of a coefficient that kind of match up. Elimination is going to be my easiest method. How I'm going to do that is I'm going to add both of these equations together. And when I do that, the 4x plus negative 4x, 4 plus negative 4 is 0, so those cancel out. So that kind of solved my issue, like in substitution, where I need to get rid of a variable, so I'm only working with the 1-variable equation. Now I have 2y plus 3y will give me 5y, 9 plus 16 will give me 25, divide both sides by 5, and I've already found my first variable. From here, what I'm going to want to do, similar to in substitution in that last step, I'm going to plug 5 in for y, and that way I'll find x. I'll do the first equation this time. 4x plus 2 times 5 equals 9. Subtract both sides by 10. divide by 4, and I'm left with x is negative 1 over 4. So a good rule of thumb, you don't necessarily have to write these equations at the top here down, but why I added these equations together before in the last step is because the x's, or the terms there, had different signs, or the coefficients had different signs. When I added the different signs together, they canceled out. So the important thing that you want to take away from this is if you have two equations with different signs, you want to add them together. In here, if I add the 2x and negative 2x together, they're going to cancel out. On the other hand, if I have a situation like this, in this right-hand equation where I have a 5y and a 5y that match up, if I add them together, they won't cancel out. So in this situation, I need to subtract them. If I have the same sign, I need to subtract. Here we'll see if I subtract both equations, these will cancel out and I'll be good to go with one variable equation from there. So the last thing that we're going to go over in this video is how to get to an equivalent system. In that last example problem, we had a 4x and a negative 4x match up, so we could easily kind of like add or subtract the equations together to cancel stuff out. In this equation, we see that in this system, there's nothing that necessarily immediately matches up. But we can manipulate both equations to get it to where we want it to be. So what we're going to do in this situation is we're going to multiply both equations to get something to match up. When I'm looking at this 2 and 3, if I multiply the top equation by 3 and the bottom equation by 2, I'll get 6x on top and 6x on the bottom. So that will get my equations to match up. The key here is you have to multiply it to everything in that equation to keep it an equivalent equation, basically. So I'm going to multiply the 3 to everything. My top equation is now going to be 6x plus 21y equals 12. My bottom equation is going to be 6x plus 10y equals negative 10. Now, from here, I can get them together. I can cancel stuff out. 6x and 6x, they have the same sign, so I'm going to subtract everything. These cancel. 21 minus 10, I'll be left with 11y. 12 minus negative 10 will give me positive 22. Divide both sides by 11. I'm left with y equals 2. Finally, I'm going to plug this into any equation. I'll do the bottom one this time. 3x plus 5 times 2 equals negative 5. Subtract everything by 10. 3x equals negative 15. I'm left with x equals negative 5.